Hi friends, we are going to see certain topics in this theory of machines. We will be discussing about cams and followers. What is actually a cam? A cam is a mechanical component of a machine that is used for transmitting motion to another component, which we call it as a follower. So a prescribed motion equivalent by direct contact. It is used to transform a rotary motion into a translating or oscillating motions, etc. The cam and follower, they always will be having a line contact and they constitute a higher pair. Okay, that I'm first result I'm stressing, they are constituting a higher pair. What are the elements of this cam mechanism? We have a cam, a follower on the frame. The cam is the driving member, which is called as a cam, and the follower is the driven member, and the frame is actually the supports the it supports the cam and guides the follower. That is the frame. Okay. So the classifications of cams we have is a radial cam, and the radial cam is actually the follower is reciprocating. That is, it is reciprocating or translates, and also in a direction perpendicular to the cam axis. Okay, so this is also called as disc clam, and cylindrical clam means the follower reciprocates or otherwise oscillates in a direction parallel to the cam axis. Okay, so this is one model. So based on the types of followers, actually we can carry it as a shape. Based on, it can be classified based on three categories: shape, movement, and also the location of line of movement. Okay, that is the location of line of movement. The first one is the knife edge follower, roller follower. Okay, the roller follower, and also first one I'm explaining this cam with the knife edge follower. When contacting another follower as a sharp knife edge, you can see that it's called as your contact, and it is also knife edge. Next one, what it is, roller follower. So what happens in the roller follower, the contacting end, you can see this will be actually the contacting part, it will be a roller, right? Next one, what it is, mushroom or follower. When the contacting end is a perfectly flat faced, this you can see is called as a flat faced follower. Okay. Next one is spherical faced follower. How it will be actually, when you take it, the follower is of a spherical shape at the contact area. You can see it's called as a spherical. In that also we have different models. Okay, these models you can have. So these are the various types of followers based on the shapes. Okay, based on the movement, we call it as a reciprocating follower. Reciprocating follower in the sense when the follower reciprocates in guides as the cam rotates uniformly, we call it as a reciprocating. And oscillating follower means when the uniform rotary motion of a cam is converted into predetermined oscillatory motion of follower, we call it as a oscillating or rotating followers. Okay. Next one is based on the line of movement, we have it as radial or offset. When the motion of the follower is along a line passing to the center of cam, we call it as a radial. And offset, actually I think so. Yeah, you can see here. All of this are the normal models. This is all are the, this is just a minute. Yeah, this is radial. Offset, this is one diagram. So offset, when the motion of the follower is along an axis, away, offset, there will be certain distance. You can see the axis, both axes will be offset by distance. We call it as an offset follower. So this is the diagram for radial cam nomenclature. So we are having different terms to depict it. Okay, the first one is your base circle. It's actually the smallest circle which can be drawn. We call it as a base circle. Okay, the smallest one. And next one is the trace point. Is trace point is the theoretical reference point on the follower, which is used to generate the pitch curve. Okay, so next one is your trace point. Okay, this is your trace point, and also the pressure angle is the angle between the direction of the follower motion and normal to the pitch curve. So pitch point means it will be a point on the pitch curve having the maximum pressure angle. Okay, so what it is actually, what is pressure angle? Again and again I am saying about pressure angle. What it is actually, pressure angle means is the angle between the line of action of the follower and the corresponding normal to the pitch curve. Okay, so that is called as your, in this you can see here, this is actually the angle between the line of action of the follower, whereas the follower to the, and also and a corresponding normal to the pitch curve, we call it as this one. Okay, now again I'll say, what is pitch curve? Isn't it? It is a curve generated by the purpose of laying of the cam profile. It is assumed that the cam is fixed. We are assuming that the cam is fixed, and also the cam is this follower is following. That's called as a pitch curve. Pitch circle. What is pitch circle actually? Pitch circle, you will have it as your the circle drawn from the center of cam through the pitch points. Prime circle means it is a smaller circle that can be drawn from the center of the cam, etc. Okay. So next one is a lift or stroke. The maximum distance maximum travel of the follower from the lowest position to the topmost position. So we call it as a lift or stroke. Okay. The motion of the follower, it can be a uniform one or simple harmonic. It can be uniform acceleration, retardation, and cycloidal motion. Okay. It can be ascending. It can be dwelling. It can be whatever be it. Okay. It can be actually based on your cam can be defined to produce any types of motions. Okay. So you can see this your displacement of follower motion with uniform velocity. Okay, the uniform velocity is also considered not so good from practical point of view. So you can see this diagram in this, etc. You can see that when the displacement diagram and a follower follows the moving velocity, we get your diagrams, etc. Since the velocity of the follower is uniform, the slope of the displacement will be always constant. Okay, that you can see that. And next one is when you are having it in this in the case of your simple harmonic motions. How it is actually, what is simple harmonic means when a body moves with actually on a circular path with the uniform angular velocity, its projection on the diameter, it's called as a simple harmonic motions, etc. Okay. You can see that you are drawing a semicircle with the lift and also dividing the semicircle, you can see into a number of points. Okay, and dividing the outstroke angle into the same number of equal points. Okay, that angle we are dividing and your project intercepts we are obtaining and we are getting this. Okay, these are some equations. And next one is displacement and velocity and acceleration diagrams, and the follower is moving this uniform velocities. Okay, so uniform acceleration and also your retardations. This actually we call it as a parabolic. You can see the parabola would have gone. Okay, the first half of the outward stroke is completed with uniform acceleration, the remaining stroke with uniform retardations. Okay, so how will we be doing this? So you will be dividing the angular displacement of the cam during outstroke in equal numbers of parts. You can take it as 6 or anything else, and dividing the follower lift into equal number of parts, etc. Okay, similarly we are meeting at we are drawing this diagram. This first will be our first you can see the outstroke, and the second this area is called as dwell. This is the return stroke, and again this will be a dwell, etc. Okay, so we can get it as a parabola. And next one is your cycloidal motion. Okay, so cycloidal moment, etc. Cycloid is the locus of point circle that you have learned loading on a straight lines, etc. Okay, and construction, what happens here, you are dividing the angular displacement into any equal number of parts and you are drawing vertical lines, etc. And from that you are drawing a diagonal line, and I am getting this model. So since it is a model of a cycloid, we call it as a cycloidal curve.
That's all.
Thank you.
Thank you.